Welcome back to this channel. My name is Dr. Arzu Chabra. I have a PhD in organic chemistry, and I am an organic chemistry tutor and also a mindset academic coach for college students. Um, just really fast, this last week we actually started off with a mindset um, coaching sessions for college students, and we are just done with 1 week of a 9-week program. And this program is purely for a survey-based program because I'm doing it in a group setting for the first time. And if you're interested in joining us for free, just you can reach out to me at the email mentioned down below in the description. And also, or I might just add a link down there for you to join our Discord channel and join us at the 4.0 Mindset program that does run on Sundays 11 a.m. EST. And if you're interested to join us, feel free to check us out. But of course, because it is a free program and I ask from you your commitment and your time and your feedback from this program to kind of make this program uh, a program that's actually well built for students that are high achievers and want to get into med school or want to focus on getting really good at their course and also focus on the other areas of their life as well. Okay, so let's get started. So today we are actually working on amino acids, proteins, chapter from Kaplan, organic chemistry. And so I think this is the last chapter that I would be working through the problems. And after this, I will be solving a few practice tests, which I would also be uploading over here. And so let's get started. And the first problem for today is if a mixture of alanine and aspartic acid is subjected to electrophoresis at pH 3, which of the following would you expect to occur? Okay, so what we really see is that alanine has a pI of 6, right? And aspartic acid, it has a pI of 3, which means that at pH of 3, right, alanine would actually be acidic, right? Because at pH less than 6, right, alanine will experience acidic environment. Alanine will experience acidic environment. And if it is an acidic environment, then it means that it is a protonated alanine, right? So what that really means is that alanine is going to have a positive charge on it. Okay, and then aspartic acid, if it has a pI of 3, what it really means is that at pH equals 3, it's going to be a neutral molecule or it will be a Zwitter ion. So then we can really say that aspartic acid, right, will probably or will actually not move in a electrophoresis experiment, right, because it is at its Zwitter ion state, right? So when it is a neutral species, it's not going to, so aspartic acid will not move, while alanine migrates to the cathode, which is also true because alanine actually is a positively charged species, right? If it is a positively charged species, then it will move towards cathode, and cathode, because cathode itself is a negatively charged species, or sorry, a negatively charged what is it called? Has a negative charge, and therefore the alanine will migrate towards the cathode. Okay. In a neutral solution, most amino acid exists as Zwitter ions, which I already mentioned. Okay. What would be the charge of glutamic acid at pH equals 7? When I was working through these problems, what I did not really like was that they did not tell you that the pKi, right, for glutamic acid is actually around 3, which really means that if when you know that the pKi is around 3, then you can tell that at pH equals 7, glutamic acid would be under basic conditions, right? Glutamic acid under basic conditions, because at pH 3 it would be neutral, right? Above pH 3 it would be under basic conditions. Below pH 3 it would be under acidic conditions, right? So this is under basic conditions. If it is under basic conditions, meaning that there would be a negative charge, right, on the glutamic acid. So because it's under a base, because there's excess of base in that solution, so overall it will be a negatively charged species. Okay. So the next problem is, if an amino acid Pi 9.74 in acidic solution is titrated with sodium hydroxide, what would be its charge at pH 3, 7, 11 respectively? And this is like a really nice question, right? So amino acid, the Pi, okay, I think I meant Pi here, not really pKi. So I really was talking about the isoelectric point. That's the point where the molecule is actually neutral, right? So if, or the pH where the molecule is neutral, if an amino acid in acidic solution is completely titrated with sodium hydroxide, so the Pi is 9.74, meaning that when the pH is 3, right, the amino acid will be under acidic conditions. And if it is under acidic conditions, it would be positive, right? So this is under acidic conditions. And so it is positive. Okay. And then if we are at pH equals 7, so if we are at pH 7, what we do really see is that it still will experience acidic conditions, because only at 9.74 pH it would be neutral. So then again we have a positive pH. Now at pH equals 11, what we know is that it would be now under basic conditions. And if it is under basic conditions, so then it would be a negatively charged species. So positive, positive, negative is the correct answer for this problem. Amino acids with nonpolar R group have which of the following characteristics in aqueous solutions? So what we know is that if R groups are nonpolar, meaning that they're hydrophobic, so something between B and C would be the correct answer. However, what we know is that when they are hydrophobic, right, they're actually found buried within proteins. So like, because the protein surface can be thought of as hydrophobic, so it just like coils towards the protein. However, like the body surface, right, or the solution of the body can be thought of as more like it can be found on the protein surface, or are buried within the protein. So if it is on the surface of the protein, then it is connected, or it's in touch with the body or the body solution, right? But however, the body is actually hydrophilic. So the hydrophobic and the hydrophilic will not match, and therefore they just choose to like recoil within the protein. So option B then is the correct answer. This is just like fact-based information, and if you understand it really well, then good. It will really help you. All the following statements concerning peptide bonds are true except. Okay, about peptide bonds form formation involves a reaction between amine groups and a carboxyl group, which is true. They're primary bonds found in proteins, which is also correct. They have partial double bond character, which is correct. Their formation involves hydration reaction, which actually is not correct because hydration reaction really means reaction with water, right? And so peptide bonds are not formed by reaction with water. It's actually just the reaction of an amino group and carboxyl group. So the correct true answer is option D. How many different tripeptides can be formed containing one valine, one alanine, and one leucine? Okay, so then how many different tripeptides? So then the answer is, if you have three different amino acids, right, then you can form 3 factorial combinations, right? If you have 3 different things, then you can rearrange them. This is like a little bit of a math problem too. You can arrange them in a 3 factorial way, meaning that you can arrange them 3 times 2 times 1. You can arrange them in 6 different ways to get different, or you can arrange them in 6 ways that will give you different answer each time. So 6 is the correct answer for this problem. Besides peptide bonds, what other covalent bonds are commonly found in peptides? Okay, of course. Besides covalent bonds, the other common bonds are actually the disulfide bonds, right? That is like the only other bonds that are actually formed on the peptides. And then alpha, again, like it's like a little bit of information base that you have to know some of these questions or some of that information. Okay, alpha helices are secondary structures characterized by, so within the alpha helices, there are intramolecular hydrogen bonds. And that's why then A is the correct answer. Denaturation involves loss of what type of structure, primary, secondary, tertiary, and or both. So the denaturation actually involves loss of secondary and tertiary, because whenever denaturation happens, it's not really affecting the peptide bonds. It's not really affecting the proteins. So it's not really affecting the bonding. So not affecting the primary structure, but does affect the secondary structure or the tertiary structures. So option B and C are affected, but not the primary structure, or B, secondary and tertiary structures are affected, but not the primary structures. And so this was a relatively easy problem set. And if you want to work with me or get in touch with me for organic chemistry tutoring, Orgo 1, Orgo 2, or MCAT tutoring, or you want to join us in our 9-week program for the mindset stuff, where we actually where I help you guys become more focused and more accountable towards your work life and also other aspects of your life, feel free to join us. And all the links will be mentioned down below. And I will see you guys next time. Bye now.